Welcome to the deep dive. Today, we're going to crack open the hood of Bitcoin a bit.
Sounds good.
Yeah, we want to understand its backbone, really, the different players in the network,
Yeah.
specifically focusing on mining nodes and full nodes.
Absolutely crucial roles.
Right. And our mission, well, it's pretty simple. Figure out what they each do, why they're both so vital for Bitcoin's, security and integrity.
Yeah.
You shared some great sources, so let's just dive in.
Okay. So maybe the first thing to grasp is why we even need these different roles. Remember, Bitcoin's peer-to-peer.
No central boss.
Exactly. No company calling the shots. So for the whole thing to work, for transactions to be considered valid, and for everyone to agree on the state of the ledger, well, you need these independent participants.
And they need rules to play by, consensus and validation, right?
Precisely. That's where the nodes come in.
Okay, so let's start with full nodes then. What's their specific job in this whole setup?
Right. Full nodes, think of them as the guardians of the rules.
Yeah.
The enforcers. Each one stores the entire Bitcoin blockchain.
Yeah.
Every single transaction right from the start.
Wow, the whole thing.
The whole thing. And their main job is to meticulously check every new transaction and every new block against Bitcoin's consensus rules.
So they're constantly auditing, basically.
You could say that. They don't mine new coins, they don't create blocks, but they are absolutely fundamental for making sure everyone plays by the established rules. They're like, the protocol police, maybe?
Protocol guardians, I like that. Making sure no one's trying to cheat the system.
Exactly that. They verify everything independently. You don't need to trust anyone because anyone can run a full node and check the work themselves.
And that helps with censorship resistance, too, you mentioned.
Yes, definitely. Because they relay valid transactions they've checked across the network, with so many nodes doing this independently, it's incredibly hard for someone to just stop a legitimate transaction from getting through.
Okay, so decentralized verification is the name of the game there. It keeps it open and trustless.
That's the core idea. And it's interesting, this concept of the economic majority, the consensus among these independent full nodes often carries more weight than just counting how many nodes there are. It's about who is actually enforcing the rules everyone else relies on.
Got it. Okay, so if full nodes are the strict rule enforcers, what about mining nodes? What's their deal?
All right, mining nodes, these are the block producers. Their main function is, well, twofold. Securing the network and actually creating the new blocks that get added to the blockchain.
How do they do that?
They look at the pool of unconfirmed transactions, the mempool, select a bunch of them, organize them into a potential new block, and then, this is the famous part.
The puzzle solving. Proof of work.
Exactly. They perform proof of work. It's a computationally very difficult task, like solving a complex puzzle. This makes it extremely expensive and hard to tamper with the transaction history.
And the first miner to find the solution gets the prize.
That's right. They find the solution, they broadcast their newly formed block out to the entire network.
And then the full nodes jump back in.
Yep. The full nodes then receive this new block and put it through its paces. They verify the proof of work, check every single transaction inside against the rules.
The whole validation process again.
The whole validation process. If it all checks out, then the full nodes accept it and add it to their copy of the blockchain, extending the chain.
Okay, so the miners do the heavy lifting, the computational work, create the blocks, secure the history, and they get rewarded for it with new Bitcoin and transaction fees.
Correct. That economic incentive, the block reward and fees, is absolutely vital. It aligns the miners' interests with the security of the network. Why attack the network if you're rewarded for protecting it, right?
Makes sense.
Plus, mining helps manage the flow of transactions, and their competition kind of encourages efficient use of the limited space within each block. And having miners spread out geographically adds another layer of resilience.
So it sounds like they really need each other. Full nodes and mining nodes. What's the synergy there? How does that interaction make Bitcoin work?
That interaction is the core of Bitcoin's trustless nature, really. It's a check and balance system.
How so?
Well, the full nodes are constantly watching the miners. If a miner creates a block that breaks the rules, maybe tries to spend the same coin twice, or create coins out of thin air, the full nodes will just reject it. Poof. Invalid.
So miners can't just do whatever they want.
Not at all. They need the full nodes to accept and relay their blocks for them to be considered part of the official chain and for the miner to get their reward. Miners propose, full nodes verify and dispose if necessary.
And miners rely on full nodes to even know what the current valid chain is, right?
Yeah.
to build upon.
Absolutely. It's this constant back and forth, this validation step by the distributed network of full nodes that makes it incredibly difficult for any single miner or even a group of miners to collude and take control or change the rules unilaterally.
Okay, so the big takeaway here is Bitcoin's real strength isn't just mining or just nodes, but this dynamic tension between them. Miners build, full nodes ultimately decide what's valid, keeping the whole thing decentralized and resistant to manipulation.
You've got it. Mining provides the security and the engine for new blocks, but the decentralized network of full nodes holds the ultimate authority on which rules are being followed. That P2P architecture with these complementary roles is the foundation. It's what allows Bitcoin to be censorship resistant, permissionless, and support all these evolving uses we're seeing.
That really clears things up. Understanding these fundamental roles feels, well, fundamental to understanding Bitcoin itself.
It really is. And, it makes you think, as digital assets become more important, what other decentralized systems out there are using similar kinds of checks and balances? Are there other ways to achieve that same integrity? It's definitely something worth pondering beyond just Bitcoin.